Welcome to our video presentation on FluidSim, a powerful simulation platforms that bring fluid dynamics to life. With FluidSim, we explore fluid behavior from gentle water flow to turbulent winds, offering precise modeling and diverse applications in engineering and environmental science. But first, let me introduce myself. I'm Francis Bustamante, and I'm here to explain the simulation of push button 1, stop continue button, and lastly, the reset button. So, let's start!
I am JHONEL BAUTISTA, together with Frencis Bustamante, and we are going to simulate and explain our activity. So given an initial condition where actuator A, B, C, and D are retract and having a 6 button where 3 push button with a sequence and an emergency stop, reset button, and a stop and continue button. Here is our constructed activity. So with a control system element, so it's composed of a power component together with a control element, a processing element which is composed of a shuttle valve, an input element composed of a 3 over n way valve with a pneumatically operated using solenoid, and last the supply element which is composed of compressed air supply, air pressure reservoir, and air service unit.
For push button 1 with the sequence of A plus B plus, then B minus C plus, then A minus C minus, then B plus C plus. For the sequence A plus B plus was controlled by a push button 1, then B minus C plus was controlled by a 3-way valve mechanically operated and labeled A plus. Then A minus C minus was controlled by a 3-way valve labeled C plus and B plus, and C plus was controlled by a 2 3-way valve labeled C minus and A minus. The table shows the connection of the labeled valve to the actuator. When the actuator is A+, it is connected to the valve push button 1. Also, if the actuator is B+, it is connected to the push button 1, C-, and A-. If the actuator is C+, it is connected to the A+ valve, C-, and A-. And the A- actuator is connected to the C+ valve. And the B- actuator is connected to the A+ valve. And lastly, the C- actuator is connected to the C+ valve.
For push button 2 with a sequence of B plus C plus, then A plus B minus C minus, then C plus D plus. So B plus C plus is controlled by the PB2 or the push button 2, and when actuator C actuate, it will trigger the push button with labeled C plus plus, which will activate the actuator A and retract B and C. When actuator A actuate, it will trigger the push button labeled A++, which will activate C and D. So with the help of the uh, A3++ valve to cut off the valve labeled C++, so it will prevent the repetition of the sequence. And using also two valves labeled D++ and A2++ to cut off the flow of air in sequence PB2. For the push button 3, the sequence is A plus B plus, then A minus D plus C plus, then B minus C minus, then A plus B plus C plus. So for A and B to actuate is to controlled by the push button 3. And then A minus D plus C plus will be controlled by a valve with a labeled of B plus plus plus, which will trigger when actuator B actuate and will cut off when actuator deactivate to prevent repetition. So, and when actuator is deactivate, it will trigger the valve labeled C++ to retract B and C with the help of the valve labeled A2 minus 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 to cut off the operation of the valve C++. And when actuator B retract, it was designed for actuator A, B, and C to actuate with the help of the valve labeled D minus 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 to have a proper sequence. So and using three valves labeled C2++, G3++, and B3++, for the cut of the flow of air to the sequence PB3. So here is the table which logically used to control the valve to the actuator. For emergency stop button, using a latch button, 4 over n wave valve. So a connection designated labeled 4 is connected to the main system, so the air supply can still flow the air to the main system, while the label 2 is connected to the track control of the actuator and also to cut off the airflow track of every push button sequence.
Next, the stop and continue button. The stop and continue button is likely used to control the simulation process. When users click stop, it halts the simulation, while clicking continue resumes it. This functionality allows users to pause and resume simulations, giving them more control over the process and allowing them to analyze results or make adjustments as needed. For stop and continue button, using an inverted 3-way valve with a latching button to control the airflow of the system. Next, the reset button. A reset button typically serves the purpose of reverting settings, data, or a system to its original state or default configuration. This action can be useful for undoing changes made by the user or restoring the program to a known starting point. The exact behavior of a reset button can vary depending on the application, but it often involves clearing input fields, returning settings to default values, or restarting a process or simulation from the beginning. Reset button is a 3-way valve using a push button connected to two track control elements of the actuator.